Hello, welcome to this lesson on permutation instructed by Mr. Johnson. This lesson is basically for high school students and college students. So let's get right into the lesson. Okay, this lesson is brought to you by Precision Academic Word. Okay, so this is a math class and let's just get into this. So this is my email address and here is a WhatsApp number you can use to reach out to us. Okay, so this is the first lesson on permutation. Let's get right into the class. So take note of a lot of information, then we'll go ahead to solving questions. Okay, according to the definition, permutation can be defined as the selection. So let's take note of this of numbers or objects and arranging them. So when you select them, you arrange them in a given order. So it has a paradigm which it follows. And don't be if you're confused about this, just relax a moment. I will explain this. Okay, I have a note here that says the number of different arrangements of n different objects is equal to the product, and this is the arrangement you are going to be having. Now, don't be confused about this or overwhelmed with the information you are seeing here. I will explain this in a minute. Okay, and then we say finally for the note keeping, this product can be written as n factorial. So we use this factorial, the notation factorial. So assume I want to write another number like let's say m. So m with this exclamation mark is m factorial. Okay, so it says that when you have n, you can break down n in so many multiples and you're going to be reducing them by one. So you can see here we have 4, we have 3, we have 2, and we have 1. Now this might be confusing for you at first, but no problem, just take it easy. Now, this rule or this law was, made by Lipschutz. I believe I pronounced it well. So this was in 1987. Okay, let's just get right and solve this question and make more sense out of what we've explained them thus far. Okay, now look at this. I have this example. Now this number for number one, example number one will have 4 factorial. Now let's write it down according to the explanation that Mr. Lip Schutz have said. So according to this, we are going to write this in the format 4 multiplied by 3. We're going to be subtracting 1 and going downwards. So when we have 4, which is the n, we multiply it and subtract 1 from it. I don't know if you get. Okay, let me just put this bracket. It simply means, just a moment so that I can understand better. So it means whatever number I'm starting from, I start from the number. So the number starting from is what? 4. I'll have to multiply it. Then I have 4 minus 1. Hope it makes sense to you. Then multiply again. Then you have 4 minus 2. Again, you have 4 minus 3. So let's check here. 4 minus 1 is 3. 4 minus oh sorry, this is minus. This is minus. I hope this is making sense to you. So 4 minus 2 is what? Is 2. And 4 minus 3 is what? 1. And we are meant to stop at 1. So that's why I'm going to stop here. So from here, you can now see that we'll be having at the end of the day, 4 multiplied by 4 minus 1 is 3, right? Times 4 minus 2 is 2 times 4 minus 3 is 1. And we're going to stop at 1. So from this end, we can now simply multiply through. So let's multiply through. We have 4 times 3 is 12, right? Okay, let's take it at once. 4 times 3 is 12. 12 times 2 is 24. And 24 times 1 is 24, still 24. So our final answer is 24. I hope this makes sense to you. Okay, so and that's it for example 1. We are done. For note keeping, you can simply write this down. I want to get rid of this so that I can solve the next question, which is example 2. Now for this example 2, which is 6 factorial, remember this is 6 factorial. I don't need to do this whole process again because that's just time consuming. I just know that I'm going to be taking it, I'm going to be subtracting 1 from this number. So the first number is 6 multiplied by what? By 5. So I've subtracted 1 from 6 to 5. So I'm just going to be going downwards, downwards, downwards. So multiply by 4, multiply by 3, multiply by 2, multiply by 1. I stop at 1. So you see, instead of me going through this rigorous process, I'll just write it in the same format and the same thing, doesn't change anything. So I hope this makes sense to you. So once you get to 1, you stop. Start from the highest number. So even if you had, let's say 11, you keep going downwards to 10, go downwards 9, go downwards 8 until you get to 1. So you just keep continue the progression until you get to what? You get to 1. So that's just what you're doing here basically. Okay, let's make sense out of this. Let's have an on-screen calculator so that we can multiply through and see what we had. So we started from 6, right? So 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So we have 720, right? So, and that's simple. Our final answer is 720, and we are done. So there is nothing much. There is no difficulty in permutation. Let's go for more examples. So I have more example. Number three is quite simple. So we just have 2 multiplied by 1, and that's 2. So we are done with that. This becomes 7. We're going downwards, right? So 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1. We have to stop at 1, right? So let's get our own calculator again. So we have 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 and finally multiplied by 1. So we have that 5040, right? So is equal to 5000 um 5040. Let's check again so that I don't make mistake. Okay, that's 5040. So 5040. Okay, now let's go to this note and take note of that. Yeah. So we have a note here, and this says that 0 factorial is equal to 1. So let's explain this. Therefore, if 0 factorial is equal to 1, if we have 1 factorial, it simply means that it's 1 multiplied by 0 factorial. So this is why we stop at 1. I just want to explain this to you just in a moment. I want to explain to you the reason why we don't go beyond 1 by multiplying through. So if you check, we always stop at 1. So why are we always stopping at 1? That's what I want to explain now. So since 0 factorial is equal to 1, now it simply means that 1 factorial is what? Let's take it to the next number. So we're not going to negative number. So the number after 1 is 0, right? So it's equal to 1 multiplied by what is 0 factorial? 0 factorial is 1, right? And as you can see, 1 times 1 is same thing as 1. So there is no need going further. And that is why we're going to stop it. So you see why we don't go beyond 1. It's the same thing. That's doing same thing over and over again. It doesn't really make sense. So that's just it. Okay, now we have this the formula that will guide us through the course of this lesson. So we'll be having n permutation r is equal to, this is r, sorry. So n factorial all over n minus r factorial. So right here, this is the general formula we'll be using to work in the course of this lesson. So take note of this. Actually, for me, I don't cram formulas. I just solve as many questions as possible. So when I solve many questions, I just get use of it. So just get the hang of it by solving as many questions as possible. Okay, so we have n and r. So I want to take note of this. So n, we're talking about number of objects. Number of objects. Okay, and then we talk about we're talking about number taken per time. So this is number taken per time. Okay, hope see if you get confused or you don't understand any part of this lesson, just pause the video and go through it again. It's well explained and detailed, so I don't think you should find any course of this lesson challenging. So let's continue. Okay, we have a question here. Now the question says you're going to analyze this question and solve it together. So we are in this together. Let's get to do it. Okay, the question says, in how many ways can 6 men, so we're talking about 6 men. So this is the number of, well, I say object or the number we are looking at. In how many ways can 6 men be seated on a bench if only 3 seats? So they said only, or even if they don't say only, so 3 seats is what is available. So this is what it can carry per time. So 6 per time are available. Sorry for that. Okay, the first thing we want to do is, okay, just a solving, let's say, ritual. You just have to write solution first or whatever. I'm just used to that. So when you write a solution, the first thing you need to do is just put down the formula. So what's the formula? N permutation r is equal to n factorial all over n minus r factorial, right? That's our formula. I hope I added factorial when I wrote down the formula before. Okay, I did. So that's just it. Okay, so back to what we have to solve. I believe this makes sense to you. Now, once you've written out this, up next, the next thing to do is to find your r. What is your r and your n? So n is equal to what? From here, we can see 6. So you can say 6 men or 6. Okay. And then r is what? What's r? We can say r is what? 3. So 3 seats or 3 per time, 3 seats. Okay, let's continue. So from here, this becomes, instead of us having n permutation r again, we are going to have 6 permutation 3. Hope it makes sense. Yeah, we are not substituting everything we have. I hope this is making sense to you. So instead of us having that, let's go straight and substitute. So this is n and r from the question. So here we have 6 permutation all over what? 6 minus 3, and then sorry, 6 factorial. 6 factorial all over 6 minus 3 factorial. So let's go ahead and solve this. 6 factorial is let's get this first. 6 factorial is it remains like that. So 6 minus 3 is what? 3 factorial. So let me just take this a little bit and so I can have more space to solve. If you want to write the notes or just put down some things, you can pause the video and take it before going down. So from here, um, we can say, let's break it down. 6 times 5. No, we are going all the way down always. So 6 times 5 times 4 times 3 times 2 times 1 all over, and we are done with that. So all over 3 times 2 times 1, and we are done with that. So what we simply do, you can multiply this and then have the total, multiply this and then divide them at the end of the day. So let's do that together and see. So 6 factorial, let's break it down. So we have 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1 finally. So that is 720, right? Okay, so we have 720 all over 3 times 2 is 6, and times 1 is same thing as 6. So finally, we are going to be left with what? 720 divided by 6. So we are left with what? 120. Okay, so 120. There are a couple of ways you can do this. If you don't want to go through this long process, you can just simply say cancel out this and cancel out this, because this is 3, 2, 1, 3, 2. So when you multiply 6 times 5 is 30, 30 times 4 is 120. So instead of you going through this process, whatever process that you find convenient for you, use it. The same thing. Okay, let's go to, okay, we have more exercise here, and it says evaluate um 5 permutation 2. So same thing is happening here always. So what do we do from this very point? We can simply say for number one, so solution for question number one, according to the formula, let's put the general formula here, which says n permutation r is equal to n factorial over n minus r factorial. So for the question number one, this becomes 5 permutation 2 is equal to 5 permutation, which is n, then 5 minus 2. Okay, so here we have 5 factorial. Sorry, I'm always calling this permutation, don't mind this factorial. So 5 factorial, and 5 minus 2 is 3 factorial, right? Okay, so let's do this. From here, you can say 5 times 2 times 3 factorial. I want to stop aside and cancel out. Then 3 factorial. I want to cancel out this 3 factorial. The same thing, even if you take the whole process. And any method is just okay, give it the same answer. 5 times 2 is what? 10. And that's 10. Okay, so let's check the next example. 8 permutation 3. Oh, I forgot to write something here. This should be 120 ways because they asked for the number of ways, I think so. So let's check the question out. Okay, how many ways? Yes, they asked for ways. Let's look at this. How they asked for ways. Okay, don't even know why I didn't remember, but it's all good. Okay, let's. The question says it's permutation 3. So number 2, it's okay. Oh, permutation 3. So this becomes 8 over 8 minus 3, right? So that's it. So here we have 8 over 8 minus 3 is what? That's 5, right? So this becomes 8 times 6, 8 times 7, sorry, just take it accordingly. So 8 times 7 times 6 times 5. So you're stopping at 5, right? All over 5. So cancel out this. And the final answer becomes 8 times 7 times 6. So let's do that together. 8 times 7 times 6. And that's what? 236. So I have 236. Did not ask for ways, so there's no need adding ways or what. So the last one, finally, we have 7. So let's just do this here, this here. So 7 then 5. So 7 factorial all over 7 minus 5 factorial, right? Okay, so this becomes 7 factorial all over 2 factorial because 7 minus 5 is 2. So 7 times 6 times 5 times 4 times 3 times 2. 2 factorial. I hope this is clear to you. Let me just clean this and write it. Okay. So from here we can see that was 7 times 6 times 5 times 4 times 3 times 2 factorial all over 2 factorial. Cancel out. So 7 times 6 times, let's just multiply 3. 7 times 6 times 5 times 4 times 3, right? We're getting 2,520. So 2,520. And we are done with that. Okay, that's just it. Okay, right here we have a task. A task, I think, 6 questions, just 6 questions for you to solve. So what you just simply do with giving a lesson already, go through the lesson and make sure you understand the concept. Then try this task. Make sure you do it on your own. Don't copy from anyone. Don't try to get anyone to help you do it. Do it yourself. Okay, you have question number 5. Just scroll down. Question number 5 and question number 6. And I haven't said that we are done. So remember, this lesson is brought to you by Professional Academic World. Do well to subscribe and like our channel. So thank you so much.